So we're going to talk about 4, 6. I'm going to try to get through all of this today, and we'll see how far we get. So, true, false. Segments that are congruent have the same length. That is true. Polygons that are congruent have the same shape, but are not always the same size. True or false? That is false, because they must have the same size. They must have the same shape and the same size. We're going to be doing similar figures one of these days, and then that would be the definition of a similar figure. In congruent figures, corresponding angles have the same measure. True or false? Yeah, in congruent triangles, corresponding angles have the same measure, so that's true. And then today, hypotenuse is one of my favorite words ever. Your favorite what? Oh, I had no idea. So your hypotenuse is always the longest side in a right triangle, and it is always opposite the 90-degree angle. Why? Because the 90-degree angle in a right triangle is 100% of the time the biggest angle. So therefore it should be across from the longest side. So look at 7 and 8. So we're not going to consider 4, 5, or 6. So we can cross those out. But look at 7 and 8. Cross out the side that is not a hypotenuse. So you do 7 and 8. Make sure that you know that the legs are the two sides that are created by the 90-degree angle, or they are the two sides that create that 90-degree angle. So on this one, these are the hypotenuse, and these ones circled are the legs. So the legs on your right triangle always create that 90-degree angle. And they're the ones that are not the hypotenuse. They're the ones that are touching the 90-degree angle, not opposite it. So then flip. Say that again? It's possible. And you've had that often, right? So now you should like these proofs. We're getting into specific congruence of triangle proofs with right triangles. What do you know about every right triangle? Every right triangle has a 90-degree angle. Whether they're congruent or not, every right triangle is a 90-degree angle, so they at least have one corresponding angle that's congruent. Whether there's another corresponding angle that's congruent is a different story. So, theorem 4-6, I like to call the HL theorem. It's called your hypotenuse leg theorem. And it says, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So if you can prove corresponding hypotenuse and corresponding legs of two right triangles are congruent, then those triangles are going to be congruent. And look at the picture here of these ones marked. So if we weren't doing a right triangle theorem, is this SAS, SSS, ASA, or AAS? Is that angle included in between the two sides? No. So isn't this ASS? Bad word, right? So this is an unusual situation. Mostly because this, and the only reason why we can spell this with a bad word, and in the past we haven't been able to prove this, is why?
This is what wouldn't all of them be because every two of them angles would be 45 degrees on both of them. So
Not necessarily 45, because these aren't necessarily congruent. Well, these won't ever be congruent. It could be 30-60. It could be 20-70. right? So I can lengthen, well, here's the deal. The reason why we can prove this one was a bad word is because this is 90 degrees. That's not changing, no matter what. And then this hinge can change. I mean, this angle can hinge out or come in, but the problem is that if I take this and make it smaller, right, but I keep that same length, won't this angle have to change and get bigger? And it's not going to get bigger than 90. So, because it has to remain 90. Prior to that, it could have been, I don't know what degree, because of this arc mark here. It could have changed depending upon the length of this side, but it still would have been the same as the other side. Does that make sense? Let's say that was 70 degrees before. I didn't know it was 70, but, and that's 70. If I change this angle here, depending upon that length, this side, this angle here, would have changed as well. So that's why we couldn't prove it, because it would have had to change to be greater than 70. But now this angle has to remain 90. It's not allowed to change.
I'm just confused as to why P and X are
P and X. Oh, why? It will be once we're done. But P and R are not necessarily 45, 45. But what I will know is that this angle here is, you're right, congruent to that angle when I'm done. And then this angle here is going to be congruent to that angle there. But they're not going to be 45, 45. Unless QR and YZ are exactly equal to PQ and XY. Because if I have an isosceles right triangle, then yes, those become 45, 45. Because in isosceles triangles, those angles opposite their congruent ones would be congruent. But only in that situation. So my point is, we now have an unusual situation in right triangles only that you can prove a hypotenuse and a leg congruent. You can prove those triangles congruent even though it's a bad word. So let's look at number 9. To use the HL theorem, the triangles must meet 3 conditions. Complete each sentence with right or congruent. There are 2. What kind of triangles specifically? Right triangles. They have to be right triangles in order to use any of the right triangle theorems. The triangles have blank hypotenuses. I call them hypotenuse. They have to be congruent. There is one pair of congruent legs. So how do the triangles in the take notes meet the first condition in exercise 9? So let's look at the take note. Where is the take note? Oh, gotcha. Right there. So how do the triangles in the take note meet the first condition in exercise 9? What's the first condition have to be? They have to be right. So the triangles are both right triangles. And how do they meet the second condition? Which would be the H and the HL. What's the H and the HL? Hypotenuse, right? So both triangles have congruent hypotenuses. And then, what's the third condition have to be? They have to have one pair of corresponding congruent legs. So both triangles have one pair of corresponding congruent legs. Okay, so look. We're going to do a flow-through proof, which you can follow along quite easily with. So let's look at what we have here. So let's see what was given. And If it's not marked up, you're going to mark it up. So angle PRS and angle RPQ are right angles. From right here, anytime you're told that that there's an angle and two triangles that are right angles, immediately you conclude that the triangles are right triangles. You have to state that you have right triangles before you can use any of the right triangle congruency theorems, and there are 4 of them. We've only just talked about one of them. So this is important, bless you, that you state this before you state any other right triangle congruency theorem. Then they told us that SP is congruent to segment QR, and so those are marked here with a single tick mark. And we have to prove that the triangles are congruent. So here we go. Given, we've got angle PRS and angle RPQ are right angles. Also given is that segment SP is congruent to segment QR. From this given, notice what they're concluding. That the triangles are what? Triangles are what? Right triangles. So we've got triangle RPQ that we have to add in there. So we've got a right angle. What piece of this triangle is that right there? Hypotenuse. So here's an H. We only have one more thing that we need to prove congruent, because it's a right triangle rather than 3. What item can we prove congruent all by ourselves without any help? Yep, so that's the same kind of recurring theme. PR is congruent to PRY, reflexive property. And then that's going to give us that piece there. What part of the triangle is that piece there? A leg. So don't we have HL? So from the given and from the fact that we have a right triangle, and so this is giving us our H, this is giving us our L, we said that PR was congruent to PR, and they have the reflexive property of congruent. What are you going to add here? Segments. We can now prove the triangle is congruent, RPQ by HL. I won't make you do a flow-through proof because I think it's easier for you to do a 2-column proof anyway. But there's walking you through that. So let's look at another proof using HL. So we're not going to go through these. We'll do our own pre-proof planning, and then we're going to fill out what we need here. So look what they gave us. CD is congruent to EA. And so that's marked. What part of the triangle is that? Look at that right there. It's a hypotenuse, isn't it? So right there. So there's an H. And then they said that AD is the perpendicular bisector of CE. AD, that's the knife, is cutting CE. What do I conclude from a perpendicular bisector? There's actually 2 things that I can conclude from that. Perpendicular, what do I conclude from that? They have right angles. So angle CBD and angle EBA are right angles. So that's one thing I conclude from the perpendicular bisector. The second thing is the bisector part. What pieces are congruent from the bisector? CB and BE. So CB is congruent to BE. And what part of the triangle are those? The legs. So this gives us an L. So we have an H and an L, and we can immediately prove the triangle is congruent by HL. So here we go. We're ignoring these. We've got our pre-proof planning done. So here's our statements. We're going to start with H. So CD is congruent to EA, segment EA. That gives us our H. Bless you, that was given. And then we're also missing here. They don't have that in here, but we're going to add it in. that we also need AD is the perpendicular bisector of segment C. We have to have that before we can conclude that angle CBD, and from our pre-proof planning, angle EBA are right angles. And so there's where that came directly from that perpendicular bisector. The second thing that comes from the perpendicular bisector is this right here. So CB is congruent to BE. So those are the two things that come from that. That gives you your L. But notice that, remember what I said, before we can use HL to prove triangles congruent, don't we have to say that we have right triangles? So the minute that I have right angles, and that's what we noted here, can't I conclude that I have right triangles? You have to say that. So you might want to highlight this because this is one that you're going to miss all the time. And then you are welcome to use the definition of a right triangle. I won't make you write that one out. So CBD, let's look and see what corresponds. We've got C, what corresponds to C on this triangle? And C is created, C is between the one tick mark side and the right angle. So here's my right angle, here's the one tick mark side. Shouldn't it be E? Not everybody sees it, my dear. And so then on here, B is the right angle. Sorry, B, there's the right angle. Wouldn't B also be the right angle on this triangle? And then that leaves us with what? What letter's left over here? A. All right, and so finally, we can prove the triangles are congruent by your HL. And so we've got CBD and EBA, triangle EBA. Now they could follow this, instead of asking you to prove that the triangles were congruent, couldn't they have said prove that AB, segment AB is congruent to segment BD instead? It could have been your proof statement. It would have been the same exact proof except for what? I know you love proofs, but you have to stay with me. It would have been the same exact proof, but what? Question or comment? So if I change my proof statement, except for this, and I took that one out, but thinking with her, and I said instead, prove that AB is congruent to BD. Based on what? So I still would have the same proof. I would still have all of this, but I'd have one more step. I'd have that proof statement that I'm asking for. We'd have an extra step. I'd say that AB is congruent to BD by what? Once I prove triangles congruent, what are these to those triangles? Come on, we just did a proof like this right before I lectured. What do you follow any triangle congruency statement with? Thank you. CPCTC, corresponding parts of congruent triangles are congruent. So you could have exactly the same proof, but if this proof statement right here is switched out by any corresponding parts, then you would end up with corresponding parts of congruent triangles are congruent. So please bear in mind that you could have that. We had that in, what was it, 4-4, I want to say? 4-5, 4-4, something like that. All right, flip it. Lesson check. So you're only having one triangle congruency, right triangle congruency theorem, and it's HL today. Yeah. Oh, what's your comment? You can just do HL. Yeah. And you don't have to say theorem. You can just do HL. I'm fine with that. All right, so I want you to look at this, and I want you to write true or false, and then do some explanations. So see if you can ponder that. We've got about 2 minutes. Okay, share your answers with those around you. Are we ready? So there's your true false answers. There are three right, listen, there are three right angles. That's false. There's only two. So there are two right triangles. That's true because there's two right angles. There are two congruent hypotenuses. That's true. That's MJ and LK. They are the sides that are across from the right angles. There are no congruent legs. That's false. They're not marked, but you can prove that LJ is congruent to LJ through the reflexive property of congruent segments. And so that's kind of what they go on to next down here. So this is false because of this, and this is false because it's not given. It just is. And so then, do you always need three congruent corresponding parts to prove triangles congruent? You just learned today that no. If you have right triangles, you only need two parts. And you only learned HL today. There are three more types that we'll learn later this week. Is your classmate correct? No. You can prove the triangle is congruent by the HL form. Yeah. What? Oh. Olivia. Well, you could. You mean for 25, to answer 25? Yes, you could say that. But using SAS tends to be longer than using HL, depending upon how you write the proof. You could prove it with, this particular one you could prove with SAS. But we're going to shorten up our proofs, hopefully, by using HL. Just another means to shortening up something that could be long. But again, remember, before you can use HL, you have to say that you have what kind of triangles first. Right triangles. You cannot use HL until you've stated somewhere in the proof, whether it's the given or somewhere in the proof, that you have right triangles.